Now let's look at difference of squares, part 2. On number 9, we notice that there is a difference. That's the first thing it needs to have. Our first base has to be a perfect square. Well, I know that 169 is a 13 squared. R squared I know is an R squared, and 9 is a 3 that has been squared. Now that I've identified the bases, open up your 2 parentheses. The first base goes in the first position. The second base goes in the second position with a plus and a minus between them. We can check any of them that we want to, as you saw at the end of the last video. Now for 121, k squared minus 196. I checked on my calculator, and first of all, a negative in the middle, that's the difference. 121 is a base of 11 that was squared. A k squared is a base of k that was squared, and 196 is a number 14 that was squared. I just kind of mess with my calculator until I find the one that works. Let's see. So since we had a difference in 2 perfect squares, I open up my 2 parentheses factors. The first base goes in the first position. The second base goes in the second position with a plus and a minus between them. Be sure to pause the video if I go too fast on any of them. On number 13, we have p squared minus 64. Pause the video for a little bit and see if you can do this one at your seats. Okay, we have the negative. The number being squared in the first position is p, and the number being squared in the second position is an 8. Since we have a difference of 2 perfect squares, you opened up your 2 parentheses factors. The first base goes in the first position. The second base goes in the second position with a plus and a minus between them. On number 15, 36n squared minus 121. Well, I don't think there's anything in common all the way across. There is a negative in the middle. The base that's being squared in the first position is a 6 and an n, and the number being squared in the last position is an 11. Open up your 2 parentheses factors. The first base goes in each of the first positions. The second base goes in each of the second positions with a plus and a minus between them. Let's look at 17. There is a negative between the 2 terms. The number in the first position is a perfect square. It is the perfect square of 10r. The number being squared in the second position is a 1. Because it is a difference of 2 perfect squares, we open up our 2 parentheses factors. The 10r goes in each of the first positions. The 1 goes in each of the second positions with a plus and a minus between them. And I do want to remind you that as long as the parentheses are identical to the ones that I've written above, it doesn't matter which order you put them in. Okay, we've got number 19. Oh my, okay. I definitely think they're going to have something in common. So I'm going to grab my calculator real fast. Since they're guessing that 13 is one of the they're asking us to pick which one of these is the answer. So I'm going to start off by dividing 637 by 13. And it comes out even. If I factor a 13 out of the first term, it's going to leave behind a 49b squared. That means I hope 832 divided by 13 is 64. See, whenever they give you possible answers, use them to your advantage. I used the first one to help me see if there was a greatest common factor, and luckily there was. Here, now that I've taken 13 out, I'm looking at the first base, 7b, second base, 8, and there's that negative I need. So letter A is going to be the answer, isn't it? Because this is going to factor into 13. Open up our 2 parentheses factors. The 7b goes in each of the first positions. The 8 goes in each of the second positions with a plus and a minus between them. Same thing on number 21. Oh, how many are there? Okay, this is the last one. We'll finish it up in this video. Now, one thing I noticed is that both of the numbers, right, because I've got the difference, both of those end in a 0, which means I can factor out a 10. So already I kind of think it's going to have to be one of these. But let's see which one. And use your calculator if you need to. When I factor a 10 out of this first piece, it's going to leave behind a 64v squared. When I factor a 10 out of this last term, it's going to leave behind the number 121. Is that a difference of perfect squares? Here's the difference. This is a base of 8 and a v. This is a base of 11. So it's going to factor into 10 and then 2 parentheses. The 8v goes in the first positions. The 11 goes in the second positions with a plus and a minus between them. So it is letter A again. And that's it. I'll see you in the next section.